Welcome to the Chromperfect training series. First, please subscribe to our YouTube channel for all the latest product and training content for your Chromperfect system. If you click the bell icon, you will be notified when we post new videos. This is our quick start guide to Chromperfect, and it provides essential information and an overview for new users. Here, we will be using Chromperfect version 8. Other versions may address certain issues a little differently. Chapter 1. About this guide. Chromperfect comes with 3 manuals. The installation manual describes how to install the hardware and software and how to configure instruments. The main manual describes every operation, feature, and option in detail. The workbook is an additional training tool, providing new users with examples and training exercises. It's a great place for new users to start learning how to use Chromperfect. This quick start video is intended to provide an overview of Chromperfect, to give new users the information they require to get started. Throughout this guide, there will be notes which will guide you to review topics within the installation or main manual. Here you will find more detailed information and instructions, as well as descriptions of advanced features which are not covered here. All our manuals are on the Chromperfect USB key in PDF format and are installed on your computer in the directory C:/cpdata/manuals. So, what will we cover in this presentation? Chapter 1, About this guide, describes what you can and cannot expect to find in this video. Chapter 2, The Chromperfect System, describes key features and an overview of how the system works. Chapter 3, Configuration and Setup, explains how to tell Chromperfect the type of instruments that will be connected, and goes over some of the initial steps that should be taken on any new installation. Chapter 4, Developing a Simple Method, walks you through the steps to develop your first method and set up a calibration file for peak identification and to calculate results. By the end of this video, you will have successfully installed and licensed your Chromperfect software, physically connected instruments to Chromperfect and set up communication with the acquisition server, developed and refined your first Chromperfect method file, acquired some chromatogram files, set up a calibration file to calculate amounts and name your components, know the difference between fixed and formatted reports, understand how to use sequence files to automate your work, have a basic understanding of the layout and functionality of your Chromperfect system. Chapter 2, The Chromperfect System. The first section of this topic details the key features of your new software. Chromperfect is designed to run on Windows 10 Professional and higher. The system can acquire, process, and report data from any GC or HPLC. Data can be acquired digitally from a network or RS-232 serial connection. Alternatively, proprietary AD converters, known as Tiger interfaces, can be used to collect analog data. Chromperfect is completely scalable, and the same software is used throughout our range of chromatography data systems. Chromperfect Standard Reports meets the needs of a large majority of chromatographers by providing area, normalized area, amount, and normalized amount results. If needed, Chromperfect has a powerful reporting tool to build customized reports. Pre-built reports are included with the software, including several listed on screen. Note: for more information about the supplied report templates, please refer to the main manual. There are also several application products for specialized needs, including those listed on screen now. These modules are not covered in this quick start guide. Contact our sales team if you are interested in purchasing any of these modules. To install Chromperfect, you will need Microsoft.NET Framework 4.5 or higher to be installed on the PC. All the files required to install and run Chromperfect are supplied on a USB key. Insert this in your PC's USB slot and locate setup.exe. We will now demonstrate how to install Chromperfect. It is advised that you accept all the suggested default settings. You will need to have your USB key inserted into the PC throughout the install procedure and as you continue to use the software. Chapter 3: Configuration and Setup. The first section of this chapter deals with directory structure. During installation, Chromperfect program files will be installed in the C:/Chromperfect program directory. Many demo files will be installed in the CP data directory. The manuals directory contains the PDF files as we described in Chapter 1. Users are expected to create folders to hold their own files. In this example, a user has installed Chromperfect locally and has created a data directory, CP Lab Data, with 2 subdirectories. In this case, the subdirectories gas data and oil data are analysis-specific. Some users prefer their directories to be instrument-specific and would give them names such as GC1 or LC3. Within the program directory, Chromperfect will create a subdirectory for each configured instrument. These are working spaces for Chromperfect and should not be used as a directory to store files. In the example, there are 5 temporary directories, as there are 5 instruments configured on this station. Let's take a moment to explain the difference between raw and bound data files. Raw data files contain the data points and associated information for a single chromatogram. During acquisition, every injection will generate one raw file for each active channel. A raw file is reliant on the external files that were used to acquire it. As method, calibration, reports, and instrument control setpoint files may change or be deleted over time, this is a serious limitation in the use of raw files for reviewing archived data. A bound data file does not suffer these limitations. Each bound file has the method, calibration, setpoint, and report files saved internally. This means a bound file does not rely on external files to integrate the chromatogram, calculate the results, or generate the reports. Each Chromperfect method will automatically produce a bound file by default. As bound files are not reliant on external data, it is recommended that you use bound files for your daily analysis. You can select bound files from the Open File dialog box within the analysis program to only display this file type. In addition to data files, Chromperfect also uses other file types which are seen frequently by all users. Take a moment to familiarize yourself with the different file types, which are shown on screen now. Other files may be created during the processing of the raw file, and their extensions are listed next. These are standard file types and can generally be used with other Windows programs. Data file names. The name of Chromperfect data files consists of 3 parts: the base name, the cycle number, and the extension. These 3 parts are separated by periods. The following file names all conform to this convention and are examples of raw, bound, Z, and PDF files. The base name can be anything the user wants it to be. However, illegal Windows file name characters are not allowed. In the simplest form of acquisition, Chromperfect will preserve the base name and automatically increment the cycle number. The file names are therefore different, relieving the user of the need to specify a new file name every time an injection is made. The extension distinguishes the type of file. Acquisition creates one or more .raw files, and there is normally a corresponding .bnd file created. Processing these files usually results in the creation of other files. As this example demonstrates, these files will retain the base name and the cycle number of the raw file from which they are derived, but they will have their own characteristic extension. Suppose that we are acquiring data from a GC with two channels, a TCD and an FID, and we choose a corresponding base file name for each channel. Let's also presume that the initial cycle number is 100. The first injection will generate the raw files as shown. The next injection will generate the raw files named with the cycle number incremented by 1, and so forth for all later injections. When each of these raw files is processed, any new files that are generated will have the same base number and cycle number, but with a different and characteristic extension as shown on screen. Note: you can completely automate the file naming process. This is detailed within the main manual. The main menu. Chromperfect is started by clicking the PC Start button and locating Chromperfect main menu in the Programs list. Alternatively, you can also create a shortcut on the taskbar. Clicking on Chromperfect main menu starts the Chromperfect Start bar, also referred to as the main menu. All other Chromperfect programs are started here. Some will be used daily, while others are used less frequently but provide important functionality for the Chromperfect system. Take a moment to familiarize yourself with the functions of each Chromperfect program as we cycle through a description on screen. Access control and security. By default, Chromperfect security is turned off. This means the user can easily open any program without being challenged. If security has been turned on by a Chromperfect administrator, then the main menu will present users with a log-on screen. The Chromperfect administrator has full control over usernames and passwords and may place restrictions on any user. When security is invoked, the form will display the name of the user. When security is not used, the form will display single user. In addition to Chromperfect security, Chromperfect is fully Windows compliant and will obey permissions set up by the PC and/or network administrators. For example, if certain directories have been set up by the administrator to be off-limits or read-only, then Chromperfect will not override those settings. Note: more information about Chromperfect security is available in the installation manual. How acquisition works. The work of acquisition and instrument control is divided between two Chromperfect programs: the acquisition client and the acquisition service. The acquisition service operates in the background. It communicates with the instruments, monitors their activity, and acquires data files as required. Most users will never interact directly with the acquisition service during normal use of the system. The acquisition client provides the user interface for all acquisition-related activity. Through this program, users may claim and release instruments, download instruments, start runs, view the real-time plot, and determine what will happen to the data files when the run ends. A quick note about starting or restarting the acquisition service. The acquisition service is required to communicate with the instruments. It must be running to collect data with Chromperfect. Normally, the service will be started automatically by Windows. However, if you ever see the following message, the service is either not running or needs to be restarted. Open the Windows Services applet and locate the service called CP/ACQ Service. After you have selected the service, check that it is set to start automatically when you start your computer. Next, click either the Start or Restart option on the top left of the form. You may have to contact your IT support team to provide access to the Windows Services applet. Configuring instruments. After the software has been installed and the instruments have been physically attached, the next step is to tell Chromperfect what types of instruments are connected to the system and how they are connected. This is called configuring instruments. Note: check the installation manual for more information on specific instrument configuration. When the software is first installed, the acquisition client's spreadsheet will be empty because there are no configured instruments. Expect to see this message the first time the acquisition client is launched. Click the button to dismiss the message and close the acquisition client. Let's now look at the process of configuring instruments when you first install Chromperfect. From the Chromperfect Start bar, choose Configure, and the following dialog will appear. Next, click the Configuration menu item. The Instrument Properties window will appear. Select the correct device type from the pull-down list. Then click the Add button for each instrument of this type, which will be connected to your Chromperfect system. When setting up each instrument, you should first select it from the list that has been created. Most instruments require a specific address, either a COM port number, a USB address, or an IP address. Some models have option for RS-232 or TCP/IP, so you may have a choice. Most instruments support more than one channel, and you may configure the instrument to use fewer than the maximum number of channels. Some instrument types support more than one model, and you may have a choice. When you have finished setting up the first instrument, press the Apply Edits button, and then move on to the next instrument, board, or unit. New in Chromperfect version 8 is support for Agilent's Instrument Control Framework, ICF. This system allows manufacturers' RC.NET instrument drivers to be used with Chromperfect. Note: a few instrument types have additional configuration items. Please check the installation manual for more detailed instructions about setting up specific instrument types. Repeat as necessary until all instruments are configured. When you are finished, press the OK button. On the next screen, you will be able to connect specific instruments to the system and can name your instruments and detectors. When you click OK, you will see the Data Acquisition Service Monitor window. If you have entered all the settings correctly, you should see Awaiting Download under Server Status. If the instrument shows offline, it is best to restart the CPACQ service in the Services app or restart your PC. Depending on the instrument type, it may take 15 seconds or so for the instrument to show Awaiting Download. If the instrument refuses to go to Awaiting Download, go back and check your settings. For network instruments, you may need support from your IT department. It is advisable to disable all firewalls and security software if you experience problems. Specific exclusions may be required to allow Chromperfect to communicate with your instrument. Chromperfect support staff cannot assist with diagnosing network issues. You should contact your local network or IT support staff to resolve any problems with instruments being offline. Now we have configured the instruments. Let's personalize your Chromperfect system and make it run more efficiently. Search directory paths and other user settings. Click the Profile button on the Chromperfect Start bar to tell the system where to expect to find your files. The Profile Editor has 3 tabs. On the Search Paths tab, press Insert to add as many lines as needed to list all data directories. If the directories have already been created, then browse to them with the button at the end of the line. If data directories have not yet been created, then type in the name of a directory. Include the path. After setting search directories, then save the changes. Note: check the manual for information regarding the ACQ server hostnames and preferences tabs. System-wide settings. If you want to change the number of digits in your raw file name, cycle number, or change the headings on reports, this can be done by clicking the System button on the main menu. Go to System, then Page Setup. You can then change the title or footer of your reports. In the Miscellaneous setting, you can set the number of digits in the cycle number of your raw file name. Chapter 4: Developing a Simple Method. If your instruments are configured and their status in the data acquisition client shows awaiting download, then it is time to begin developing a Chromperfect method. It is the Chromperfect method that provides the instructions for collecting and processing data. This can be quite simple or more complex depending on the settings within the method. In this next segment, we will demonstrate how to develop a simple method. We will begin by using the file editor to create a new method which has the correct settings for acquisition. Before peaks can be named and a calibration file created, a raw file must first be collected so there is something to work with. To collect this raw file, we must first create a basic method file. This method will be edited during development until it provides the desired results. Because this is our first use of the file editor, we will begin with a brief introduction. As its name implies, this program allows you to edit many Chromperfect files. Go to the Start bar and click on the Files button. The program will start. When you open the file editor for the first time, the Edit Existing File dialog might open. There is a checkbox which can be set to show this form every time you start the program. As we want to create a new method, you can close this form if it appears by clicking the Cancel button. Now select File and New from the drop-down menu. The following form will appear. Now click the Method button. The Method Editor form will now appear on the screen. Most of the tab sections control the processing of raw files after they have been acquired. Later, we will return and adjust some of these settings, but for now, we need only set the Acquisition tab section. There are many items on this tab section, but only 3 are crucial to acquisition. The runtime determines how long acquisition will take place. It need only be somewhat greater than the retention time of the last peak of interest. The sample rate determines how often the software reads the detector signal. The chromatographer's rule of thumb is that there should be at least 10 data points across the full width of the narrowest peak of interest. If you don't know, enter 20 for a GC or 5 for an LC. The Acquire From channel setting does not matter if the instrument has only one configured detector. In a multi-detector instrument, these settings determine which of the configured channels is active as far as acquisition is concerned. We wish to acquire data from all channels, so check as many boxes as there are channels. The other fields on the Acquisition tab need no attention currently. When you have finished editing, pull down the File menu and choose Save. When the dialog appears, give the new method file an appropriate name and save it in one of your new directories. Download the method and collect a raw file. Clicking the Run icon on the Start bar starts the Acquisition Client program. There are 2 tabs to the Acquisition Client. These tabs are on the far right of the form. The Selection tab is shown with its yellow spreadsheet. In this illustration, there is one newly configured instrument which is awaiting download. The first time you use this program, there are several things that must be done on this tab. Should you close the Acquisition Client, most of these settings will be remembered when you return. Make sure that the Show Plot and Auto Proc checkboxes are checked and that the other checkboxes are unchecked. Press the Browse button to select, instrument by instrument, the directory to which all newly acquired raw files will be sent. Go to the Printer column, pull down the drop-down list, and choose a printer for each instrument. This selection determines which printer will receive the end-of-run report should the method call for one. To control an instrument, first you must claim it. Go to the Control column and press the Claim button for an instrument and move the cursor away. After a second or so, the button caption will change to Release. This is your confirmation that the instrument has been claimed. Next, click the Status tab on the right, and the spreadsheet with the blue background will appear. Clicking the Control icon brings up the instrument control form. Click on the Download button to download your method. This form has several tabs, but for now, we need only concern ourselves with the Acquisition Parameters tab section. Every run requires a governing method file, which determines the acquisition parameters. Type in the name of your method file or press the Browse button. When a method is selected, the other fields become editable. Most of these settings simply provide names and numbers which will go into the raw files as they are acquired. Most of them may be left blank for now. The only critical ones are these: the base name and the cycle number. These together determine the name of the raw and bound files which will be created by the next run. For example, if the base name is My Data and the cycle number is 1, Then the raw file will be named mydata.1.raw, or perhaps mydata.0001.raw, according to the system-wide settings. Bound files of the same name will normally be created automatically. The method file determines how the acquired data files are processed. In a single-channel instrument, the only channel is channel A, which is processed according to the governing method file. In a multi-channel instrument, the several channels represent data from different detectors, if not different columns. The responses and even the retention times may be different, so each channel needs its own method and calibration files. Therefore, the other channels require the name of a processing method file, which names the appropriate calibration file for that channel. Each channel also requires its own base file name, so you can identify the different files associated with each detector. If you are using an autosampler, set the vial number. If you are using a 7890 with an autosampler, set the injector to ALS. Before we leave this form, see that type of run is currently set to Analysis. Later, when we have built our calibration file, we will discuss how standards can be run and the calibration updated automatically. The options are Calibration Replace, to replace the responses in the calibration file with new data, or Calibration Average, to average the new results with the existing responses. As you select either of these calibration update options, the calibration level field becomes available. We will cover these calibration options later, so for now, keep the checkbox set to Analysis. When you have finished editing all channels, press OK. The download form will disappear and you will return to the previous form. You should now see your raw and method file names in the spreadsheet. The instrument status should change from Awaiting Download to Ready. Before we close the instrument control form, there are other important options. Although we are not going to cover these in depth within this video, it is important you are familiar with their functionality. Change runtime. You can change the runtime to increase the run if needed. This can be done even when data is being acquired. Change download. Edit a sequence that is currently running to add or delete a sample. Show special features. Check this box to access the instrument panel. You can also upload setpoint files, instrument parameters, from a Direct Connect digital instrument. Relays. Shows the state of the relays on Tiger interfaces, and you can change these manually here. Prepare to inject a standard sample. If you have an autosampler, the run should start immediately after the injection. If you are injecting manually, start the instrument as soon as you have injected. In either case, you should see changes in the acquisition program. The instrument status should show the elapsed time and the real-time plot, or plots, should appear. Expand the plot as necessary to see the peaks as they come out. You can change the plot scale by selecting Scale from the Plot menu item or by using the mouse. To change the scale with the mouse, draw a box with your left mouse button, then move the cursor inside the box and click the right mouse button to confirm. Repeat until you are happy with the new scale. You can use the shortcut key Backspace on your keyboard to go to the previous level of expansion, or pressing O will return to the original scale. When the runtime elapses, the plots will vanish and the cycle number will increment. Alternatively, you can stop the run early by pressing the Stop button on the Instrument Control dialog box. This will save the current run and create your data file. Or if Abort is pressed, the run will terminate, but data will be discarded and no file will be saved. When the status returns to Ready, this is your indication that Chromperfect is ready for the next run. Sometimes the instrument may take a while longer, so instrument status may change to GC not ready, but eventually it will change to Ready and you can make the next injection. Proceed to collect runs until you have at least one good data file, in which all the peaks of interest are well separated and exhibit their proper retention times. Optimize the integration. Now that we have one or more data files to work with, we may optimize the method file. There are two tasks before us: to verify that the sampling rate is correct and to set the integration parameters. We will do this by using the analysis program, which will soon become familiar to you. Let's quickly explain what happens when you open a bound file in the analysis program. When a bound file is created, the processing method file is saved to the bound file. When you open the bound file, the analysis program will automatically read this internal method file and will integrate the file according to the method settings. If the method file name's a calibration file, then that will be automatically applied. Go to the Start bar, click on the Analysis button. When the form appears, pull down the File menu, choose Open, and then hit the Browser button. When the File dialog box appears, you can make a selection to show only bound files. Chromperfect should remember this choice next time you open the program. Let's open some sample chromatograms with a known method and calibration file. Multiple files can be opened by using the standard Windows Selection Tools Control-click or Shift-click. Plots within Analysis display not only the chromatogram trace, but also baselines, peak retention times, component names, and additional information according to the method file settings. Let's close these files and open one of the bound files that you have just created. The first thing we should check is whether your sampling rate is okay. To check the sampling rate, we must view the individual data points. Open the Properties dialog box from the Plot menu. Explore all the tabs on the Plot Properties form. You may alter the plot decorations simply by checking and unchecking the various boxes and pressing the Apply button. Go to the Label tab. Make sure that the Retention Time box is checked. Go to the Draw tab. Make sure that the baseline box is checked and check the data points as dots box. Press the Apply button. The easiest method of changing the scale is by using the mouse as we discovered in the Run program. Using your left mouse button, draw a box around the peak or peaks of interest. Move the cursor inside the box and click the right mouse button to confirm. Roughly count the data points across one of the narrowest peaks. There is little need to have more than 30 dots across the peak. If there are less than 10, then you should go back, open your method file, and increase the sampling rate, then save the method file. This will affect future raw files, but not those already collected. You may wish to collect another set of raw files before proceeding here, but that may not be necessary. Unless the sampling rate is very low, you can forge ahead with the file you have. Let's move on to some other things that should be considered. The example illustrates a problem that frequently appears even when the sampling rate is adequate. Not all the peaks have baselines. In this case, only 3 peaks were recognized. This indicates that the integration parameters, the threshold and the peak width, are not optimum. The proper values must be chosen by the user, but there are tools which will suggest appropriate values. As we improve these parameters, more baselines will appear, and more peaks will become decorated with retention times. Let's now optimize the integration. Pull down the Plot menu. Choose the Peak Properties tool. Use this tool to select peaks in the chromatogram by left mouse clicking. The dialog box shows the peak properties, and we can see what the peak widths of several of your peaks are. You may want to record some of these to try to determine an average. Close the Peak Properties window. Pull down the Plot menu again and choose Measure Noise. Use the mouse to define a region of the chromatogram that is free of peaks. Right-click to confirm. The software will report the noise level and suggest an appropriate threshold. You can record this value and enter it manually. Alternatively, you can select the option to use this setting and it will automatically be applied. Pull down the Integration menu and choose Automatic. The Integration Options form will appear. Enter the suggested peak width and threshold values and click Apply to see the effect. Adjust these values until all peaks of interest are integrated. A lower threshold makes for more detected peaks. If the threshold is too low, the baseline will be littered with tiny peaks. The effect of the peak width is less easy to characterize. Once you find a combination of peak width and threshold that works for your entire chromatogram, pull down the File menu and choose Save Method. You will be presented with the opportunity to change the name of the method file, but simply press OK and your new settings will be written into your method file. What if it doesn't work? Ideally, you will be able to arrive at some combination of peak width and threshold that will work for the current chromatogram and for all future chromatograms that use this method. But sometimes this is impossible. Perhaps there is a disrupted baseline due to the switching of a valve. Perhaps the peak width increases with the retention time, so no single peak width setting is appropriate for all peaks. In a situation like this, Chromperfect needs additional hints to integrate the chromatogram properly. These hints are called timed events or integration events, and they are stored in the method file. Note, there are a great many of these events which are described in the main manual. Pull down the integration menu and choose Insert Event. Select a suitable event to accomplish the desired effect and insert it at the appropriate time on the chromatogram. On the Select Event form, there is a thumbnail at the bottom that shows the effect of the event. You can place the event with the left mouse button and then confirm the operation with the right mouse button. There is also an operation assistant which explains the process. When you have added all the necessary events, then save your method file as described above. The timed events will appear into the Events tab of the method, along with their retention times. These times are absolute, so be sure to place the event so that the inevitable slight peak shifts, which occur from run to run, do not cause the event to be in the wrong place relative to nearby peaks. Timed events should be monitored and adjusted as needed. There is one more important step before we move on. We have saved our method, but this will only affect the new data files which are acquired from this point. The internal method of our current bound file remains unchanged, so we also need to remember to bind it to our data file. Think of this step as similar to saving changes to a word processing document when you have made an edit. This will ensure that the various changes that we have made will be saved to the file. Don't worry, Chromperfect will prompt you to bind your file before closing it if you have made any changes. However, it is important that you realize the difference between saving a method file for future data collection and rebinding a bound file to save the changes that have been made. Let's create a calibration file. Now that the integration has been optimized and the integration parameters have been saved, it is time to name the peaks of interest and to build the calibration file. There are 3 ways to do this. Option 1. Manually update the cal table in the file editor. Go to File Editor, create a new calibration file, and then type in the component names, the expected retention times, and the search window widths. This is the most manual way of building a calibration file, and it will give you valuable expertise in editing calibration files. But if there are more than a few components, this procedure is too tedious for most people. Option 2. Use the information from a bound file as a template. Go to the File Editor. Create a new calibration file and select the option Use the peak information in a bound file as a template. Go to the File Prompt control and pull down the Recent Files list. You should see the name of the bound file you just saved in Analysis. Select this file and press OK. A calibration file will be created which has a component for every peak that was integrated, whether it is of interest or not. The names are just Peak 1, Peak 2, and so forth, so you still must type in the correct names. But the expected retention times are filled in, and so are the search window widths, so you have avoided much tedious work. This is a reasonable option for most people. The third option for creating a calibration file is to use the graphical capabilities of the analysis program and then finalize it in the file editor. Within the analysis program, open your recent chromatogram. Select the Components menu item. Select Make New Calibration File. Then modify Components and Add. Left-click on the peak of interest and right-click to confirm. The Add Component dialog box appears. The expected retention time and Windows width fields are already calculated for you. However, we will look at changing these graphically in a moment. Enter your peak name and amounts into the fields. The response is already entered for the area of the peak. You can change this to height using the checkbox. Click OK. Next, you can use the left mouse button to change both the window width and expected retention times. Grab the blue tram lines and increase or decrease the window width size. Grab the peak label at the bottom of the plot to change the expected retention times. Confirm your changes by placing the mouse cursor within the blue tram lines and click the right mouse button. Select your next peak and repeat the process for all peaks of interest. With a little practice, this can be a fast and intuitive method for creating calibration files. When you have named all your peaks, save your new calibration file by selecting File and Save Calibration File. You can also edit existing calibration files, and you can experiment with these features by selecting Component, Modify Component, and Edit Graphic. Creating a calibration file in Analysis is a great way to name components and capture the retention times of those components automatically. As with all aspects of Chromperfect, the calibration file can be set up simply, or it may be called upon to perform more complex tasks. Indeed, at this point, your calibration file may be ready for use if area or normalized area data is all that is required. Additionally, if you are using only a single-level external standard and the information about that standard has been entered, then your calibration file may also be ready to go. However, there can be a lot more to a calibration file. Finalizing the calibration file. You may need to open your cal file in the editor to make additional changes so it is fit for purpose. A new calibration file will list all the named components, the retention times of those components, the area or height distinction, and a single calibration level with an amount and a response. All other fields will be in default condition, including the settings at the bottom of the Component tab. Unidentified peaks are peaks that are not listed as components in the calibration file. They are not deliberately in the calibration standard. Nevertheless, it is often desirable to calculate amounts for these peaks, for example in petroleum analysis, where the number of peaks greatly exceeds the number of standards. The solution is to apply to the unidentified peaks the calibration curve for one or another component in the calibration file. This component is called the default component for the unidentified peak. New calibration files have no default component, so the amounts of the unidentified peaks are all 0. You can change this setting to specify a specific component, or you may specify the previous, the next, or the nearest component. If your application requires either more than one calibration standard or replicate injections of the same calibration standard, then you must add more levels to the calibration file. You can do this by clicking the Insert Level button. In the example here, a second level has been added, reflecting a standard, which has been run twice. Responses from both standard analysis is captured in the calibration file and applied to the unknown. Responses for the new levels can be entered manually if known. Alternatively, if files have been reviewed in Analysis and saved as a bound file, then values can be updated by clicking the Perform an Update button on the Miscellaneous tab. Be sure to select the level that is to be updated at the top of the form. Also, review the various options about how the update will be performed. The descriptions should be self-explanatory. However, refer to the main manual if needed. Browse to the bound file that represents the level and click OK to perform the calibration update. Going forward, the calibration file can be updated automatically during acquisition. You may remember in an earlier section, we discussed the calibration replace and calibration average options. This was on the instrument download form in the Run program. When running samples, you can choose these options to automatically update your cal file by indicating the level that will be updated. Look on the Statistics tab for important measurements about how well your data fits your calibration curve. At the end of editing, be sure to save the changes made to the calibration file. Note: read about the calibration file in the main manual. The additional columns found on the Component tab can provide important functionality. Also, check the Chromperfect YouTube channel where we discuss some more complex calibration and peak identification techniques. Finalizing our method file. Now it's time to put the calibration file in the method. Open the method and click on the Processing tab. Locate the calibration file name field and use the Browse button to select the calibration file just created. While you are on this tab, Consider the file options at the bottom of the page and check those that you wish to create automatically at the end of the analysis. Bound files are created as standard. We recommend that you keep this option selected in your method. Also, if another chromatogram will be subtracted or the chromatogram will be smoothed, then these steps can be done automatically at the end of an analysis if some selections are made on the Processing tab. Click on the Report tab of your method. This will determine what reports are created automatically when this method is used to acquire data or to batch reprocess existing files. There are two sections on the Report tab: the Fixed Format Report and the Formatted Reports. The Fixed Format Report section is where you can get a standard pre-made report by simply checking the boxes. To include a chromatogram, check the box. The Plot and Plot Options tabs are used to size and set the labeling options of the chromatogram. The text portion of the report will provide amount, normalized amount, area, and normalized area data. The checkbox Report Text is referred to in the analysis program as the Fixed Short Form Report. If the With Detailed File Information is also checked, then there will be more information in the header section. This is described in the analysis program as the Fixed Long Form Report. The data table is the same in both the short and long report. Note: the SEC checkboxes are to be used if the SEC application has been purchased separately. We do not cover this option in this video. The Formatted Reports is where you will list formatted files created with the Custom Report tool. The custom reports can be created in lieu of or in addition to the standard fixed format report. Custom reporting is a powerful feature of Chromperfect. There are detailed instructions on how you can customize and build your own reports within the main manual. As the method is developed, more features on other tabs will be brought into play. Create a sequence file. A sequence file should be thought of as a list. The most common use of a sequence file is to prepare a batch of samples for analysis, but there are many other uses for them which are detailed within the main manual. It is time to validate the method and create a sequence file. Our sequence file will download the method and acquire new data files. These files will be processed first to update our calibration file and then to analyze several samples. This section assumes that you have prepared all the necessary calibration standards and that you have one or more samples to analyze. We will prepare a sequence file which contains the information necessary to acquire and process these injections. Create a calibration injection list. It will look something like this. Here we list 2 calibration standards, each of which will be injected twice. These 4 injections provide the data to update the calibration file, 1 level for each injection. Your calibration list should reflect the actual number of standards, replicates, and levels in your calibration file. We don't consider channels in the calibration injection list. If your instrument supports multiple channels, then you will have multiple calibration files, which must conform to one another in terms of standards, replicates, and levels. After the calibration injections, we will run 3 samples. These are to be analyzed according to the newly updated calibration file. These analytical runs do not involve an update, so the calibration level is 0. Create a sample injection list. It will look something like this. So let's create a sequence file based on our calibration and sample lists. Go to the File Editor, pull down the File menu, and create a new sequence file. You will be presented with 3 options. Choose Empty File. You will be presented with a spreadsheet form with a single line in it. Press the Insert Entry button until you have an entry for each injection, 7 in the example. Adjust the Channels List box to indicate the number of channels on your instrument. If we change this to 2 channels, you will see 2 rows per entry, 1 row for each channel. The row headings will change to 1A, 1B, etc. At a minimum, you must supply 4 items: the raw file name, cycle number, method file name, and calibration level. If you are using an autosampler, you must supply the vial number as well. The sample name is handy, but not necessary. The 4 numbers do not matter because they support features in the calibration file which are not turned on yet. Also, review the Copy Down and Copy Down with Increment buttons. They can save you time entering data to the sequence table. Review the settings, then save the sequence file. Supply the name mytest.seq or any name you like. You can now use your sequence file to acquire data by clicking the Run button. Where to go from here? The instructions in this guide were deliberately limited to those which are necessary to get new users up and running as quickly as possible. To do this, we avoided mentioning the possible variations and complications. Now that you have your simple method in hand, you should consider how it must grow to fully meet your needs. All these topics are fully explained in the main manual. Alternatively, please review other, more advanced training videos on our website and YouTube channel. Thanks for watching.